Okay, we're going to test each of these equations for symmetry to the x-axis and to the y-axis. So the equations are kind of backwards. If we want to test for symmetry to the y-axis, we replace with a negative x. If we want to test for symmetry to the x-axis, we replace with a negative y. So let's start with symmetry to the y-axis, which means that we're going to swap in a negative x. So this is going to be y is negative x squared plus 4, which gives us y is x squared plus 4. So because this is the same as the original, right? This is the same as the original equation. That means we are symmetric with respect to the y-axis. If we were to do the same thing for the x-axis, which means we're plugging in a negative y, we would see that negative y equal to x squared plus 4 is definitely not the same. There's no way to fix this negative sign, so to speak. Even if we multiplied everyone by a negative 1, it would throw the signs off on the right side. So it is not symmetric with respect to the x-axis. So I would actually just stick with this as your final answer, okay? So let's do the same thing for our second question. So first up, let's check our y-axis. Okay, so now that's a negative x is y squared minus 3, and it's kind of the opposite problem we had in the last question, right? This is not going to be symmetric with respect to the y-axis, okay? But let's try the x-axis. So we've got x is negative y all squared minus 3, which means x is y squared minus 3, and that is the same as the original. So we are symmetric with respect to the x-axis. Okay. Down here for our third one, scroll up a bit. If we check the y-axis, we'll see we have negative x all squared plus y squared is 16, which means x squared plus y squared is 16, and that's the same as our original. So we are symmetric with respect to the y-axis. And then if we do the same for the x-axis, you'll see that we have x squared plus negative y all squared is 16. So x squared plus y squared is 16, which again, this is the same as our original, so we're symmetric with respect to the x-axis also. Right? So in this case, we have both equations, or both axes that we're symmetric to. Okay? Here, if you're looking at the y-axis, you've got 2 times negative x plus y is equal to 4. Let me scroll a bit. Which is a negative 2x plus y is 4, which means no, we're not symmetric with respect to the y-axis. So let's try for the x-axis. Again, plugging in the opposite variable. So plus a negative y is 4, 2x minus y is 4. And again, there's no fixing this. There's absolutely no way to make it look like our original. So this is also not symmetric with respect to x-axis.